Hello. So we are discussing network analysis with graph theory, and in this video we shall briefly see how to form the edge incidence matrix from a graph. Okay, suppose I have a graph like this with 4 nodes, and let me name them as A, B, C and O maybe, or D, and let there be edges connecting these nodes from A to B, B to C, between A and C, between B and O, between O and C, between A and O. And all these edges are directed edges, so we have chosen arbitrarily, quite arbitrarily, some reference direction of this edges or the current that flows through these edges, like maybe from left to right, from it in this branch, maybe again left to right, maybe here right to left, maybe here bottom to up, here top to bottom, here bottom to up, quite arbitrarily. And then what else do I need? I just need to name these edges. I have to give some name so that I can identify them easily. And let me name this edge as 1, this edge as 2, this edge as 3, this edge as 4, this edge as 5, this edge as 6. It's just a name. Okay, now I have to form the edge incidence matrix, which is nothing but a table. It's a table where this side, or one side, any one side you choose to start with, it's convenient to choose this side to represent different nodes, and this side to represent different edges. Okay, so here we have 1, 2, 3 and 4 nodes, so we should have 4 rows for node A, B, C and O. We have 6 edges, so we should have 6 columns, 1, 2, 3 and 4, 5, 6. 1, 2, 3, 4, 5 and 6. Okay, and then we will fill up this table with the elements such that consider a particular edge. So first consider an edge, consider a particular edge, any particular edge. Example, edge number 1, let's consider this one. This edge, so edge 1 is here, so it starts from node A and stops at node B. Edge 1 starts from A and stops at B. So we will put 1 plus 1 against this node A. So this is the edge that I am considering, and this starts from node A, so I put a plus 1 here, and I put a minus 1 at B. So plus 1 at A and minus 1 at B. So here at B I put a minus 1. So that means this node, this edge number 1 starts from node A and stops at node B, and it doesn't go to node C, so I put a 0 and a 0 because it doesn't go to node O at all. Similarly, now let's look at edge 2 next. Edge 2, so edge 2 is here, it starts from C, stops at B. So starts at C stops at B. So put a +1 against C and -1 against B. So here at C I put a +1 and here at B I put a -1. And then 0, 0, because H2 is not connected to node A, H2 is not connected to node O. Similarly, let me fill this table up now a bit quicker. Node 3, this one starts from O, go to B. So starts from O +1, goes to B -1, 0 and 0. H4 starts from A to O. So A to O means +1, -1, 0, 0. Then 5 is here. So it starts from O and goes to C and 0, 0. 6 starts from A +1, goes to C -1, 0, 0. Okay, so this is called an edge incidence matrix or simply incidence matrix, and it's generally denoted with the letter A, capital A. Okay, so this is how to form an edge incidence matrix. Now, as a continuation to this talk, I just add one more definition, which is called reduced edge incidence matrix or incidence matrix. Okay, so what is that? I will tell you that now. Okay, in this matrix, okay, if you remove any one particular row, any one node, you choose any node in this circuit. Let me choose this one, and I remove the row corresponding to this particular node. Then the remaining remaining matrix, which is now 3 by 6, is called a reduced incidence matrix. You can remove any one row, any one, which means any one node, and this is, as we go on we will see, is equivalent to, in circuit analysis, choosing this node as the reference node for circuit analysis, or in other words, we choose the potential of this node to be 0. This node is earthed or reference, and we remove the entry or the row corresponding to this particular node. You can choose any other arbitrary node as the reference. You can choose B as the reference, then remove B. But do not remove O, then remove only one row. Any one, but only one. Okay.